Good afternoon. My name is Hannah Gardner, and I'm a sophomore here at the University of Alabama studying microbiology and neuroscience on the pre-medical track. Today, I would like to discuss my project, the implementation of Research PACS for Enhanced Medical Image Archival, which is supervised under Mr. Rishi Deshpande of the UA MRI Facility, as well as the Department of Psychology. Now, if you asked me a year ago if I would willingly enclose myself inside of an MRI machine for research, I would have believed that you were crazy. Little did I know that I was the crazy one, as these images represent more than just a snapshot of my human anatomy. They symbolize the intersection of cutting-edge technology and the pursuit of better healthcare. As a student stepping into the field of medical imaging research, I've had the privilege of working directly with these MRI scans, exploring ways to not only capture these intricate details, but to revolutionize how they are stored, sorted, and accessed. Throughout my ongoing work on optimizing a research PACS system, I've tackled challenges in image organization and accessibility, striving to make this technology more intuitive and impactful. Today, I'll share how this research holds the potential to enhance patient care and streamline medical workflow. The University of Alabama's MRI Research Facility has been the foundation of this project, offering both cutting-edge technology and a collaborative environment for innovation. It is a 9,700 square foot research center containing 2 MRI bays for research and training, and it is an extension of the ALRI, also known as the Alabama Life Research Institute. Its purpose is to grow neuroscience research for both faculty, staff, and students, as well as understand more about the growing and developing human brain. In my role at the MRI facility, I've been focusing on improving the digital infrastructure behind these machines, and ensuring that the images they produce are not only high quality, but also seamlessly integrated into research workflows. So my objectives include improving Orthanc and DICOM categorization for better sorting of MRI images by patient ID, name, and referring physician, specifically, as well as enhanced image viewer functionality for faster and more efficient access to MRI scans. And then the significance of these is to streamline the management and retrieval of medical images, reducing time spent navigating patient data, as well as increase efficiency in clinical workflows, enabling quicker diagnoses. And lastly, support optimal image handling and workflow in a 2 MRI bay. So a few terms I want to define. PACS, also known as the Picture Archiving Communication System, is a digital library where doctors store and organize medical images, which helps them quickly find and view patient images. DICOM, which is Digital Imaging and Communications in Medicine, is a universal language for medical images, which ensures that machines, such as MRI scanners, and systems, such as PACS, can share and understand the images and information. And Orthanc is a translator and organizer, and it's technically like a lightweight tool for helping manage DICOM files, especially for smaller clinics or research setups. And how they a little bit interlink. PACS connects to DICOM because it relies on that language to handle images. And Orthanc works with both PACS and DICOM to help smaller setups or specific needs. So a little bit of the flow of all these terms and the medical imaging that follows. So firstly, the MRI scanner, or any of those radiology, cardiology, ophthalmology that you see on that image, captures the detailed images of the patient's body and converts them into digital data. And then secondly, the images are saved in the DICOM format, ensuring compatibility and easy sharing across medical systems. And then thirdly, Orthanc is a lightweight server that stores and organizes these images, making them easily retrievable. PACS is then a larger system that archives and organizes the images for access by healthcare professionals for diagnosis and treatment. And then lastly, these doctors can access these images through a viewer connected to PACS or Orthanc to analyze them for diagnoses, like you see right there with the workstation and its own computer and so on. So my methodology included 4 steps: setup, development, testing, and security, where setup included defining my system environment, mostly Linux, and also integrating DICOM files for medical image handling. And then secondly, with development, I wanted to add functionalities such as sorting by patient ID and name, and also adding a referring physician column. And then lastly, improving the image viewer for displaying DICOM files. And then thirdly, for testing, I wanted to validate new features with test datasets and ensure functionality and user-friendliness. And lastly, With security, I wanted to implement measures for data protection, such as encryption, and ensure compliance with HIPAA policy and other standards. And so far, my accomplishments include integrating Orthanc Explorer 2 into the existing system, enhancing the accessibility and management of DICOM images within Orthanc, adding and configuring multiple image viewers, including OHIF Viewer, VolView, and StoneWeb Viewer, expanding the visualization capabilities, and improving experience for clinical staff as far as viewing, and gaining proficiency a little bit more in the Linux commands and Python itself to implement automation and scripting solutions, optimizing image management. And then for future plans, I hope to continue these efforts to enhance DICOM categorization by adding additional sorting columns, streamlining patient data retrieval, and improving the image viewer functionality for faster diagnoses. So, in conclusion, my research shows that integrating DICOM, PACS, and Orthanc is essential for efficiently managing MRI images, ensuring seamless storage, sorting, and access for timely diagnoses. However, there is still room for improvement. The goal is to further streamline this process, minimizing delays and making the transition from MRI to doctor's analysis more efficient. By refining workflows, we can allow healthcare providers to focus more on patient care. This project has been a step forward in bridging the gap between imaging technology and clinical practice, and I look forward to continue this work. So looking to the future, the MRI Research Facility aims to enhance diagnostic efficiency by refining its imaging workflows and integrating new technologies. This will not only improve clinical outcomes, but also provide the facility's impact across diverse medical fields. Additionally, increasing research capabilities will drive innovation in imaging technologies, positioning the facility at the forefront of medical advancement. And these improvements will help accelerate both patient care and groundbreaking discoveries in medical imaging. Thank you for your time and attention. If you have any questions or would like to know more, my name is Hannah Gardner again, and my project director, Mr. Rishi Deshpande, in our emails. Thank you so much.
On slide 7, you talked about HIPAA and security concerns. I'm not sure I understand like some of the actual details you did. So like the previous slide on 6, the flow chart or the flow of the medical imaging there on 6, there's a lot of probably data files flowing everywhere. So what kind of strategies have you used to address some concerns about security?
Yes, sir. So I wanted to make sure that I actually understood what was technically happening at first. Being a student, a college student, I didn't really exactly know what was happening at first. So I wanted to discuss more with Mr. Rishi Deshpande, and I was able to incorporate VolView, StoneWeb Viewer, and OHIF Viewer, which are viewing imaging functionalities that you can add to make sure that you can click into someone's file and making sure that all of their detailed imaging, such as my brain, is there. And so that was a big step for me because, yes, that was already implemented into the system, but it allowed me to further advance my knowledge in how I could further improve it for future semesters.
So it seems like you still have a lot, like you make a lot of headway on this project, but you still have a lot that you want to accomplish. I guess my question is, how do you prepare the system for those future enhancements that you intend to do, specifically like improving image viewing and stuff like that for physicians?
Absolutely. So I did include those 3 viewers, which really was a main headway, just because those viewers were technically not in the system that I was working with, because there was the main system that is actually for the MRI imaging and scanning that they use for genuine imaging and scanning. But I was in one of those testing computer systems where I could add that and make sure I knew what was happening for future semesters, meaning I now feel like I have a better understanding of where my methodology is. It took a little bit of time, but I feel like I've finally grasped what my future methodological approach will be.
So just like looking at this slide, it seems like a lot of your work kind of has to do with getting the images from the MRI or from whatever detection device to basically the physician's like workstation or whatever they're going to use to like analyze that. Has any part of your project or any future work maybe concerned with like transferring images to like patient side things, like a patient portal or some sort of, I don't know, patient access to information?
Yes, absolutely. I think that so the system that I'm working with is technically Orthanc, which is a type of PACS. And so Orthanc can be accessed throughout multiple devices, including anything from your work laptop to the doctor's work laptop to your own. So I think it's a universal application. Thank you.